Adversary simulations are quite important for large organizations because they should have visibility on what threat actors are targeting them, as well as what type of attacks they receive. In this exercise, we will talk about TA505. And in this video specifically, I will talk about threat intelligence and how we can talk about threat actor TA505. In kill chain, the first step is reconnaissance. That's why the threat actors collect more information about their targets, such as who could be the right person to get in, what can they do with the right system, and how they can run this exercise or campaign. Reconnaissance is quite important, and it requires open source intelligence components, threat intelligence components, and some additional data to reuse, such as data collected through dark web or some other resources. In this simulation, we won't collect any additional data about our target, because target is a made-up environment for us. We will develop a TA505 exercise which can run on almost all systems. Our targets will be cutting-edge, patched Windows 10, .NET 4.8, and AMC, which means Windows Defender, enabled and running. So our exercise must be designed to run on universal systems, the newest ones. Therefore, I provide my reconnaissance phase as threat intelligence information collection as well as threat intelligence analysis on TA505. My threat attack provides us TA505 profile that is accessible through Group 92 link. TA505 is a financially motivated threat group, and they are active since 2014 and actively targeting financial institutions. This includes also APAC area as well as Australia. That's why I picked up this TA505, because they are quite active and they develop their components as well as Tradecraft constantly. In my threat attack database, we have their techniques used and a summary information collected for them, as well as their toolsets. They are called software. Finally, there are references that we will also investigate shortly, and what we will do with those references is quite important, because we will actually mimic TA505. As a part of this reconnaissance phase, I prepared a presentation. It is still under development while we are recording this video, but this video recording will show you the brief information about TA505. More information can be collected by yourself. My threat attack link will be the first starting point if you need to learn more about TA505. First of all, the techniques. The techniques are limited here. However, TA505, just like the other threat actors, they use additional techniques when they compromise the target. For example, if they compromise a target system and get the initial foothold, they may change their scenario based on the environment they have access to. If the target environment based on Linux servers or Windows servers, they may use different types of exploits. If they only focus on the money transfer and financial services in that organization, they may use only RDP or SSH tunneling-like features. We will talk about their details, but these techniques used are common techniques identified by the threat intelligence providers, as you can see the links and references here, and brief information. Also, my threat attack navigator can help you to actually minimize those links to understand as well. My threat attack navigator is available on GitHub.io. So you can actually work on this application to filter out threat actors' techniques over all threat actor features on all matter attack environment. This will simply give you some threat groups as option, as well as some additional features as well. Yeah. Okay, our threat groups are here, and I'm currently picking up TA505. APT and TA505 right here, and I use select. I also color them red, so now we have colorized MITRE ATT&CK IDs over the MITRE ATT&CK map. This may help us to narrow down what techniques to be simulated. If you go back to the original story, which is the MITRE ATT&CK group profile, we can see the real-life logs and actual campaigns. I prefer Cyber Reason's analysis because Cyber Reason has an extensive analysis here. Yeah, it is here. TA505 runs multiple campaigns, and over years they also update their Tradecraft. Therefore, these Tradecraft tools and techniques, they actually represent differently in different threat intelligence reports. Some of those are quite extensive and explain everything and how it works, but some of those are quite brief. That's why I will work on this Cyber Reason, but I also give you the links for the other threat intelligence reports I used as well. This one is a simple diagram. TA505 starts with a phishing email, comes with a link file or an Excel file. Excel file has DD component or a macro, and they led to MSA exec. And then first compromise, initial compromise here, and then they have an infected machine. But this doesn't exactly work like that because the details are quite important. First one is the macro. Macro is DD, and it uses MSA exec only for download, not for execution exactly. So they focus on some other components. MSA exec is used for downloading the first stage. They also use an LOL bean, and then they use this LOL bean to load their actual malware. This is the folder downloaded and unpacked, and this can be used as an executable line. As you can see here, they use run-dll32 to install their PegasusDLL. And there is also additional information about NSExecDLL and what type of LOL bean has been used, living of the land beans, and DLLs. As you can see in details, NSExecDLL actually created by Nullsoft. It is signed, but it is LOL bean in our terminology, living of the land. It's a trusted binary developed by a legitimate company, signed as well, but it can do some things that we can leverage as adversary or reverse engineer. PegasusDLL, on the other hand, that is our actual malware, and it is also signed. When this malware starts running, it does a lot of different things. Some reconnaissance, some information collection, and if the command and control server assigns, it also persists using registry keys. These are the information, again, collected through this analysis and campaign. And we can see more details here, such as what type of server has been used, what type of communication has been used. They use actually a C2 domain to deploy multiple stages of the campaign. such as WMI exec was downloading a file, it was available on a certain domain. It is also called C2. But there is also real-time communication, and it is also called the second C2 in this threat intelligence report. And the communication is also captured, and as you can see, the commands are visible. It is based on HTTP. So we know a few things here. First, our attack is starting with an Excel file. Excel file was using a macro, more specifically a DDE. And this leads to MSI exec to download a file to unpack. And that file has also two different files, DLLs, and this leads to code execution. Based on the threat intelligence report, through the diagrams, we can see how it works. And when the malware starts running, it also starts PowerShell commands to collect more information. Now, if we go back to our information, we need to design a kill chain for this exercise. This is the kill chain summary of this exercise. Reconnaissance phase is simply collecting threat intelligence data, mapping all of those, and developing the tools specifically to simulate these attacks. In addition, the weaponization phase. Weaponization phase is required for us as well, because we need to prepare our environment. We need to stage our attacks. How many stages we will use, or how many bypasses we will use, or how many defense evasions we will use are actually quite important in this stage, because we need to develop some of those. In this exercise, I actually prepared an Excel file using Excel anti-donut tool that I will demonstrate in the weaponization phase. And also I used a Patak loader. Patak is a purple team tool used for command and control, C2 communications, as well as malware. And I also developed a certain loader for this exercise. This loader is used through the Excel file to load the Patak implant that I will demonstrate as well. However, it first loads the MC patcher. I also reutilized an old MC patch. It didn't work in the first place because it's an old patch and Windows Defender has additional controls now, but those controls are quite easy to bypass. And I will show you how we can modify an MC patch and how we can make it working again. I also developed another tool called Ransomling, which is a safer ransomware tool. These are most time-consuming stages of the exercise. Delivery is slightly easier because this is an assume breach principle, and our assumption is the user will execute the file we presented, which is the Excel file. What we need to do is, first, the Excel file should not be malicious. Second, it shouldn't raise a lot of warnings, one or two maybe, but that's it. And the other one is, it needs to run smoothly. It should not warn the user. It should not show anything to user. And that's why we need to deploy our attack in multiple stages: Excel file, loader, MC patcher, Patak implant, and some additional files. These are called stages. Patak implant simply uses a staging environment on Patak service for the third-party binaries. Patak itself, Patak implant, server, loader, or MC patcher, they're all clean. So Windows Defender cannot raise any alerts on them. However, the other third-party tools will need some extra treatment. That's why MC patcher is there and sending Defender somewhere else. Exploitation phase is execution of Excel file and our attacks, which are defense evasion attacks, making that Excel file running, escaping from the Excel file, and then getting some execution, managing MC, and doing some additional implant actions. Installation is simply adding persistency to the registry. Command and control phase is running the Patak service and driving the implant remotely, running some .NET applications, and forking Metasploit framework for the interactive communications. Finally, we have actions on objective spaces. They are simply .NET applications or PowerShell applications, or ransomware running for ransoming, Metasploit framework running for additional exploitations, and etc. So these are actually called kill chain, and more details are available on Lockheed Martin kill chain webpage. And now this is simply designed for TA505, but not only for TA505, as you can see, as they use some certain software called Float, AMI, Float, Grace, SDBot, Surf Helper, or TrickBot, also Cobalt Strike. We don't have access to all those tools. We need to make their imitations. So they need to simulate them. And that's why I have a Tradecraft map and technique map. The Tradecraft map is simply showing that we replace some of those tools. Float, AMI, Float, Grace, and also Surf Helper. They are the malware. Initially DreadX as well. Some of those are leaked software and open source software. They are actually modified by TA505. Also, Surf Helper is the almost latest one. In addition, they use a dropper. Patak loader or Patak dropper is the replacement for this SDBot. SDBot is the dropper, and previously it was called Get2. Get2 was deploying Float, Grace, Float, AMI, and some additional stuff. But SDBot is deploying the other ones, such as Surf Helper. So TrickBot is a spyware for their long-term engagements, and I use some .NET tools to simulate some of those activities. They also use Cobalt Strike. That's why I replaced this using Patak service. They also use TinyMet, which is the Metapredator modified version. It is here as Metasploit framework as well, and I also use Metasploit framework as is in this exercise. The technique maps also explain how it will go, and they will be updated through the exercise. Simply what I have customized for this exercise is Patak dropper, which is the loader we used. It simply loads the assemblies, .NET assemblies from remote. I also developed an Excel file using Excel NT-donut, and the file will be still presented under this repository, as well as Patak dropper. And I use an open source tool for it, Excel donut, so you can easily use it. Patak implant and Patak service, they are the implant and service, as I mentioned before. Ransomware is a simple tool that runs on .NET Core and .NET 4.5, and maybe even lower versions as well. It is a safer ransomware implementation. It encrypts a certain file or decrypts it. It currently uses hard-coded keys, but you can easily change this as parameters. Because of the time constraints, I just left it as is. Patak MC Patcher is also the MC patch, and it runs with .NET 2.0 easily, and it is quite easy to deploy, and it simply gives us a quite good test bed. This will be our target environment. Our target environment will be the employee laptop and 2 servers behind of it. The servers will be inaccessible to us. What we see here is sending the Excel file from attacker to employee. Employee will simply run this Excel file, and after that we will have access to the servers. The stage will work just like this. The Excel file will run, Excel file will load the Patak dropper. The stage 2, the MC patcher will be loading from remote to run. After it runs, the Patak dropper also calls Patak implant on this safe test bed, and Patak implant will start communications with Patak service. All this path is no initial Windows Defender detection. Patch helps us to avoid Windows Defender for non-signatures as well. And finally, this is fileless malware, so there is no file saved on disk. Patak implant is in memory, and MC patch is also in memory as well. And they are simply started with Patak dropper, and the file will be seen as Excel file initially. After the initial compromise, we will actually deploy the attack like this. Metasploit framework and attack service will take the stage. Attack implant will fork the metaoperator safely, and metaoperator will run with Metasploit, and it will use some additional modules available on it as remote access, as well as exploitation will be there. And attack implant will utilize some ransomware operations, some .NET applications, fundamental actions such as file operations, getting a file, running some certain commands, or linking additional implants, and native shellcode injections. The native shellcode injections, process injection is also starting this metaoperator as well. Lateral movement stage is slightly easier as well. So simply, we will use some name pipes and TCP connections, HTTP connections to compromise the remote servers through tunneling. And this is how we will do. And this is the reconnaissance phase. And this is how we collected our threat intelligence data, analyze the threat actor, and try to make it aligned as much as possible. Thank you.